Hello everyone. Hi. Okay, so I'm Upasana and I'm going to present how I learned to stop worrying and love structured exceptions. Yes, but before that, a little bit about me. I'm a Perl programmer. I'm working at booking.com. You can contact me via email and IRC. My email address is me@upasana.me, and I'm Upasana on irc.perl.org. So I'm going to tell you what I did in summer of 2013. In summer of 2013, I wrote code for around 200 moves exception classes. I made moves through instances of those exception classes. I wrote test cases and documentation for all those 200 moves exception classes. In short, 368 files changed with 23,830 additions and 1,479 deletions. And I'm not crazy, I did not do it for free. GNOME Foundation and the Perl Foundation paid me $5,000 for this work. So I'm going to tell you a little bit about GNOME's outreach program for women. I told about it yesterday as well, if you have seen my lightning talk. So GNOME's outreach program for women helps people who identify as women or cis or trans to get involved in free and open source software. It involves tasks apart from coding as well, like documentation, testing, community management, support, etc. And Wikimedia, Linux kernel, OpenStack Foundation, and Mozilla are some of the regular participants. Perl participated only twice, and now it will participate third time as well. Most structured exceptions were done via OPW by me under mentorship of Sean Moore and Jesse Lohers. Many thanks to them. So here begins the technical part of my presentation. After this presentation, I hope you people will be able to understand these topics. Types of errors, namely in-band errors. In in-band errors, I'll describe autodiaphragma as well, then string errors, and then structured exceptions. Now I'm going to tell you how to handle each type of error, various problems with different types of errors, how one type of error is better than the other. It sounds funny, but one error can be better than the other. How you could define your own exception classes while working with moves, and future of moves exceptions. So first of all, in-band errors. In-band errors are seen in those functions which return output and error information on the same channel. They are common in C and Perl. Here's an example code. Here I'm calling open function for opening a file named output. Now open function returns an undefined value on failure and a non-zero value on success. But what if I forget to check the return value of open? In that case, Perl interpreter will exit silently if a file named output does not exist on my system. And it is a very common mistake that people do. Like I also did it once. I wrote a script for overwriting a file. First time I ran it from root user and it all worked fine. Second time I ran that same script from my own user, but the file was not getting overwritten, and I spent quite a few time in figuring out that I do not have write permission for the file. Now good things and bad things about in-band errors. Good thing about in-band errors is they inform me about the errors at least. Bad thing is that errors may go unnoticed if you forget to check the return value, which I showed in the previous example. So how to stay safe with in-band errors? You could use autodiaphragma if you forget to check the return value. and it is written by, AutoDie module is written by Paul Fenwick. Here's an example code. Here I'm using AutoDie pragma before calling the open function. If everything goes fine, then it will print no error. If something goes wrong with open function, then it will print error from open. And if something else apart from open goes wrong, then it will print not an error AutoDie error at all. So next is string errors. String errors are those errors which just have a string message. Sometimes they have a stack trace also. They are thrown using die, croak, and confess in Perl. And older versions of Moose used to have string errors. Is there anyone who do not know what is Moose? It is fine. Seriously?
Getting trolled by Vivasuchi. Achievement unlocked.
Okay, is there anyone? Okay. Then there is an example for explaining string errors. Here I'm creating a person class using Moose. It has two attributes, namely name and age. So name is a read-only attribute, which means that I can pass a value for name only while instantiating an object of class person, not after instantiating the object. The name is a str, which means a string. So if I'll pass a non-string value for name, for example an integer, then Moose will throw an error. Then name is required, which means that while instantiating an object of class person, I have to pass name, and if I don't pass name, then Moose will throw an error. Then age, which is a read-only just like name, it is an int, which means integer. So that means if I'll pass a non-integer value for age, then Moose will throw an error. Then age is also required. So as you have described that this code is capable of throwing 4 or 5 errors. Here is code for string error handling. I'm using try-tiny module. In the try block, I'm instantiating a class, instantiating an object of class person. I'm passing Mr. Moose as name, and I'm passing XYZ as age, and I'm doing it deliberately. And as you can see, XYZ is not an integer, so it should give me an error. So in the catch block, in the first if condition, I'm checking attribute age does not pass a type constraint because. So yes, so and if I'll get this error, then my code will die with a message, what your age is ... Well, I could have fetched the wrong value passed for age, but I didn't, because I'm not going to parse the error message for fetching the wrong value passed for age. Then in the second else if condition, I'm checking whether attribute age is required, whether I've got this error or not. And if I've got that error, then my code will die with why didn't you give age. So here, as you can see, that I have I'm catching only 2 errors and not other 3-4 errors, because if I'll catch other 3-4 errors use for string errors, then it will make my code look ugly. Then my slide will go big and it will not fit on the screen. So I've skipped all those errors catching. So next I'll show you that there are some better ways to fetch wrong value and how to handle errors in a better way. Now, good things about string errors. In string errors, error information and output are separate, unlike in-band errors, which is a good thing. Then they are more informative than in-band errors. For example, in some cases, string errors also have a stack trace, which is of course more useful than in-band errors. They can't go unnoticed easily, unlike in-band errors. Now, bad things about string errors. If-else blocks, as you have seen in my example code, though there were only 2 if-else blocks, but if I would have tried to catch all the errors, then there would have been 5, 6 if-else blocks, which will make my code ugly. So second is, if someone changes the error message, then my error handling code is useless. Even a character, even if I change a character in the error message, then it is very much possible that my error handling code will become useless. So if you want more information, then there are some ways. Use carp always module. Then parse the error message, which you could do, and have more if-else blocks and make your code look ugly. Or use structured exceptions, which I'm going to describe next. Now, structured exceptions, also known as exception objects, they contain information in the form of attributes, which are generally stack traces and error message. There could be many more attributes depending on the type of exception. They are common in Java, C++, and latest version of Moose also has exception objects. Now I have defined that same person class. I repeated the code. I have changed nothing in this, so I'm skipping this. Now there is code for structured exceptions handling. Till line 9, it is everything same. In the catch block, as you can see, that in the first if condition, I'm checking whether the exception object is a Moose exception attribute is required. Now, as if you remember, there were 2 attributes, name and age, and they both were required. So that attribute is required can be thrown for both name and age. So here, I can easily fetch the attribute name by just a simple call, which I'm doing at line 17, that my attr name is equal to exception attribute name, and I'm dying with a more user-friendly message, like why didn't you give attribute name, which could be either name or age. And in this case, it will print die, why didn't you give age. Sorry, in this case I won't get this, sorry. Okay, so in the next else if condition, I'm checking whether I've got validation failed for type constraint. Now here I'm also fetching attribute name, that for which attribute I've passed a invalid value, and then I'm fetching the wrong value which was passed, and I'm dying with a user-friendly message, that is what your attribute, in this case it would be your age is XYZ, and if it could have been name, then it could have also been for name. In that case, it will print what your name is 1, 2, 3. Okay, so as you can see that I have covered all the exceptions in less lines of code, and it is not making my code look ugly. And if I would have tried to catch all the exception in case with string errors, then it would have been really, really ugly. So good things about structured exceptions. They have easily accessible attributes, as you people have seen in the previous slide. They are explicitly verbose, like you have an option like if you just want the error message, you can just have error message. If you want the whole stack trace, you can have that too. So you can control it. Then cleaner code. As you have seen, there were fewer if-else blocks as compared to string errors. There was no regular expression matching for error messages like string exceptions, which is good, which means that my error handling code does not depend on the error message. It depends on the exception object. Now, role matching could be used in catch block. Some exception classes are using common roles. For example, there is a role in Moo's code base, which is Moo's exception role class. There are quite a few exception classes which are using this role. So if you are expecting 2-3 errors which are 2-3 exceptions which all are using the same role, then you could just check for this role instead for checking each exception separately. So that's a good thing. And then ability to improve exception messages freely. As of now, there are so many modules which depend on Moose and CPAN, but they all are not using exception objects since they are not really old. So, but once they all will start using exception objects, then we can change exception messages freely, because there are some really crappy exception messages inside the Moose code base which really needs to be changed. Then easier to inspect stack trace for custom error handling, since it is just a devel stack trace object which has a really cool API, and it really helps a lot in debugging. Then now it is really easy to override how Moose format errors, since all of the error formatting is now at one place, that is Moose exception class. So if I want to change anything in error formatting, I just need to change in Moose exception class and nowhere else. Earlier there were calls to die, croak and confess all over the Moose code base. Now there are only die exception objects and no die string, die with a string or confess croak. Now documentation of exception types, I have documented all the 200 exception types, not manually. For that, I have written a documentation generator thanks to Moose meta class support. It really helped me a lot in writing that automated or documentation generator. Now, there are some bad things about structured exceptions. It made Moose heavy, 200 files, and it made Moose a bit slow, but we have tried to overcome it by loading specific classes at runtime using require class name. Then you need to create a new file for every new exception. Then polluted meta CPAN search results because of 200 exception classes, though it can be solved, but we have not yet tried it. Then Perl's built-in exceptions are strings and everybody is used to them, but but people who are coming from other backgrounds like Java, C++, they might like it. Then user-defined exceptions. If you are using Moose, then you might like to define your own exception classes. For that, you can use throwable, which I'm going to describe next. Throwable is a Moo role which provides mechanism for building exception classes. Is there anyone who do not know what is Moo? Okay. Moo is similar to Moose. It provides most of the functionality which Moose also provides, but the difference is that Moo have less dependencies than Moose. So Moo is like Moose minus dependencies. So if you want to stay away from dependencies, then use move and not moves. Okay, so throwable is a move role, and it provides a mechanism for building exception classes. It provides a throw method, and it comes with throwable error, which is a basic error class. It also has support for stack trace handling, and it also provides support for devil stack trace object. It you just need it's a one argument constructor, and it provides support for stringification as well. Now here is an example. I'm using throwable for defining my own exception class. Here at line 3 I'm using throwable. At line 4 I'm using overload, which here what does it mean is that if whenever someone will get my app error, someone will get an instance of my app error class, then he or she will get the value of message as an error message. So it also has an attribute called message. Then at line 12 I'm throwing an instance of the myapp error class using throw method, which internally calls new for creating an object. So if someone will get an instance of myapp error, then she will get invalid argument as the error message. Now, future plans of moves. So we plan to modify some cool exception messages like cannot have an is a option and a does option if the is a does not do the does on attribute, whatever. Okay, there are so many, there is not so many, but there are some cool exception messages like this in moves, and they really need to be modified. But we'll only be able to do so once moves dependence will start using structured exceptions. So please use structured exception instead of string exceptions. So please modify your code to use structured exceptions so that we can modify such cool exception messages. Then factoring out common behavior among classes and making roles for them. Like as I told you in good things about structured exceptions, that there are some classes which have common roles, but there could be more. So we just need to figure out the common behavior and make roles for them. Then making user-defined exceptions work with moves. As of now, you need to use throwable if you want to define your own exception classes, because moves util throw exception, which moves code base uses to throw exceptions, works with only moves exception namespace, but it should also work with namespace which do not belong to moves exception. So we plan to make user-defined exceptions work with moves. Then structured exceptions were very first and very tedious step toward improving moves error formatting. As I told earlier, that now we can improve error messages freely, and that's same thing almost. As of now, here's an example. If you get this attribute is required exception, then useful information is at the bottom of the stack trace. Though there is no hard and fast rule, useful information could be at the top, at the bottom, or in the middle of the stack trace. I've just taken this example. So we can make it better by playing with carp level. It is a bit complex, but it can be done. And carp plan and some other cpan modules are really helpful for this job. If you want more information about structured exceptions in moves, go for Moore's manual exceptions manifest, which contains documentation about all the exception types. And yes, it is the automated documentation generator. So if something goes wrong, then please don't blame humans. Okay, then Perl doc Moore's manual exceptions. If you want to know how to work with Moore's exceptions, then you can check out my mentor Sean Moore's blog. That link is not really complete, but I'll publish the site somewhere, and then you can copy that link. Then for defining your own exception classes, you could check out Throwable official documentation. Then for how to catch exceptions, you could check out TryTiny module. Now here the list of credits. I would like to thank these people in no particular order. For John S. J. Anderson, I stole some of the exception handling code from his talk. Sean Moore, my mentor Sean Moore, and Chris Prather for reviewing this talk before I presented here. Then Tobias Attiker, because he suggested me to add in-band errors. Yuval Cogman, I stole some of the disadvantages of structured exceptions from his blog post. Then Moore's dev channel on irc.perl.org for helping me with some of the structured exceptions, not some of them much. For in-band errors, I went to this link. For AutoDie, I checked out official documentation and inspiration behind the title of this talk, Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb. And really thanks to GNOME Foundation and the Perl Foundation and Enlightened Perl Organization, because I'm here because of these organizations. And thank you. Any questions? Thank you.
I'm wondering if this could be used for something like HTML form handler, which is Moose-based, and something at my work. What we've done is we've written a kind of bit of a hack of a class to handle form errors, and it would be nice to have something like this integrated with that could have structured exceptions for web forms.
Okay.
Do you know if that would work with that, or has anyone thought of that?
Well, I have not really explored it. Okay, I'm not really much into web development.
That's a good thing sometimes.
But yes, I have seen my mentor's slides. He presented, he gave a class at YAPC North America about structured exceptions. In that, he described HTTP throwable and some related classes. So I can tell you about it after this, because I...
Okay.
Okay. Anyone else? Oh.
Sorry, I wasn't really paying attention, and Sawyer is really shy, but he just didn't understand. He asked me to ask you, are you actually recommending people convert to structured exceptions, or we can keep using the old ones?
Now I'm going to repeat this talk. Seriously. Okay.
Thank you.
Do you really mean it?
He's always stupid, but he doesn't mean it.
It is implicit with him.
Do you think someone will port this to Moo?
Sorry, someone
Do you
will?
think that someone will port your work to Moo?
Part you. Sorry, I did not get it. Port to?
To
what?
Moo. That someone will implement this in Moo instead of Moose.
Oh, Moo. Well, maybe it could be done, but then of course that Moo will also become like Moose, that it will have lots of dependencies. So I really don't know if someone will work on porting it to Mu. But yes, it could be done. Again.
No, this is a good
Serious,
answer this time.
okay.
Yes, no, I can actually answer the.
Okay.
Shut up. I can answer the other question. I didn't see who asked it. Structured inceptions in Mu are very unlikely to happen in the Mu distribution itself, but they are very possible as an extension, just like, for example, the type system is provided by TypeTiny, written by a different author, but it integrates with Mu really well. So if you're interested, come talk to to the development team at HashWeb Simple, and we'll see what we can do. So it is an interesting idea. It's almost I don't see how it can become a core part of Mu, but as an extension, yeah, absolutely.
Thank you for becoming serious. Anyone else? No questions?
Is this your first talk?
It was supposed to be my first talk.
Well, it was awesome.
Thank you. No questions? Okay.
We got the point.
Thank you. Yes.
Shit, I have to convert my code base.
Okay, just one more thing. If I would like you, if you find any mistakes in my slides, or if you want to suggest how could I improve my presentation skills or anything related to Moos or so, then please come and talk to me. Thank you.
You need to swear more in your talk.
Shut up.
No, don't listen to him.